So we'll calculate this, verify whatever values you have calculated in the earlier calculation using law of sines. So I'll transfer this 15 Newton force to opposite side. Okay, so I'll just write it over here. So this is also 15 Newton. And so this R is 15 Newton and is 25 Newton. These three forces are forming the triangle. Okay. And so we have to assume one of the values. So let's assume the value of R which we have calculated from the which we have obtained from earlier calculation. So R we have got it as 37.15 newtons from the earlier calculations. Okay. Right, so let's mark these angles. Let's call this as gamma. This angle be gamma and this angle be beta. Right. So let's apply the sine rule. So by sine rule, I need to know the three forces and at least one of the angles. So let's calculate this angle. So I need to know this angle. So this is 30 degree. All right. So this will be 60 degrees. All right. And this with the vertical is 15 degrees. So let's just construct a reference line. This is 15 meters. All right. So this is also 15 degrees. Okay. So this angle this will be 75 degrees. All right. So the total angle is 60 plus 75. So that is equal to 135 degrees. And this force is 15 newtons. Right. So we have all the three forces of the triangle. So now let's apply the sine rule. Okay. So R divided by sine 135 is equal to 25 divided by sine gamma is equal to 15 divided by sine beta. Right. So take R is equal to 37.5 and for now let's just calculate the value of beta. So calculate and tell me what is the value of beta. So just write the equation if you want. 37. So I'm using this and this. So 37.15 divided by sine 135 is equal to 15 divided by sine beta, and we want to find out what is beta. Yes, anyone? What is beta?
(16.5 degrees).
Okay, so approximately it is 16.6 degrees. So alpha will be 90 minus this small angle, that is 30 minus beta. So that comes out to be 76.6 degrees, which is the same which we have got in the earlier case. All right. So we have verified the whatever values which we have calculated in the earlier step by using the sine rule. Any questions? Can we continue?
Yes, sir.
All right. So now let's calculate let's make P is equal to 45 and Q is equal to 15, and let's calculate the resultant. So R is equal to square root of P square plus Q square plus 2PQ cos 45 degrees. Right? P is equal to 45 and Q is equal to 15 newtons. And so calculate R and also calculate the angle tan phi, that is angle with respect to T, that is equal to Q sine theta divided by P plus Q cos theta.
R is 56.6.
Okay, so R is 56.6
56.6.
newtons, correct, and phi is 56.6 is the correct answer.
10.79
10
or
point,
10.8.
10.8 degrees, correct. All right. So this is how the resultant looks like. So now here in this case phi is less than 15 degrees, so it comes on the right left hand side, okay, of the vertical axis. Okay, so alpha is 90 minus 15 minus 5, so that comes out to be 85.8. Any questions? Can I continue? Everybody's getting the answers?
Yes, sir.
Yes, sir. All right. Now let's again verify this by using law of sines. Okay, so P is equal to 45, Q is equal to 15 degrees. So this is vertical angle. This angle is, so let's transfer this force over here. Okay, so this is 15 newtons. Okay, and let's mark these angles. So phi is 10.8. So this angle is 10.8 degrees, and this, let's draw this vertical line. Right, so this angle is 15 degrees, and this one will is 30 degrees. Right, so the angle between the vectors, this is 180 minus 15 plus 30. So that comes out to be 135 degrees. Right? So now let's we have assumed in this case phi is equal to 10.8 degrees, and we'll find out the value of resultant. Okay, so let's apply the sine rule. So R divided by sine 135 is equal to 15 divided by sine phi is equal to 45 divided by sine gamma. Okay, so this is gamma, right? So we know phi is 10.8 degrees. So using that, find out the value of R. And let's check if you are getting the same answer.
Yes, sir.
Okay, so R is again you are getting it as 56.6.
56.6.
So, all right, so you can
So
verify
that
your
will be
answers.
10.8.
10.8 is this angle phi. The angle made by resultant with 45 Newton.
Okay.
This is phi. All right.
Sir, what is a 15-degree angle?
15-degree angle
Next to
is the angle made by this. See, this is 15. See, if I construct a vertical line, this angle is 15 degrees, right? So by alternate angle, this also becomes 15 degrees.
Okay, okay.
Right? So this angle is this is 15 degrees. So alternate angle, this also is 15 degrees. So total is 180. So the angle which is included is 180 minus 15 plus 30. All right. Any other questions?
No.
Okay. Let's
So
do
in the
one more.
diagram, in the question, the arrow next to 15 is what is that representing?
What? Which one?
The arrow between P and A.
Arrow between 3 and 8.
P and A in the question.
P and A. Arrow between.
Ah,
So this is the direction of the force.
acha. No, no, no. The curved arrow.
Curve arrow that indicates the angle. So
Angle
this is
between
how
what?
you mark the angles, right?
You know, no angle between. No, not this one. The other
This one,
angle.
this.
Yes,
So
yes.
this, so this is marked in this way actually. Right. So this is marked in this way. This is how you mark the angles actually. So I already marked the arrow, curved arrow over here. So I am not going to mark a separate curved arrow for 15 degrees. So I'm just going to use this arrow and this arrow to mark the angle between force P and the vertical axis.
Okay.
That is just the convention which is followed
Okay, sir.
to mark the angles.
Yeah.
All right. Any other questions? Can we go to the next question?
Yes, sir.
Okay, let's go to the next question. So a disabled automobile is pulled by means of rope subjected to two forces as shown in the figure. Determine the magnitude and direction of the resultant algebraically. Okay, so resultant. So let's resultant will be R is equal to square root of F1 square plus F2 square plus 2 F1 F2 cos theta. Alright. So let's call F1 is equal to 4 kilonewton and F2 is equal to 2 kilonewton, and the angle is, this is given as 30 degrees, this is 25 degrees. So total angle theta is 30 plus 25, so that is equal to 55 degrees. Alright, so substitute and find out the angle resultant R, and find out alpha is the angle made by R with F. Alright, so that is given by tan alpha is equal to F1 sine theta divided by F1 cos theta plus F2. So try to understand the formula. How we try to, if you try to remember, see alpha is to be calculated. I am calculating here alpha with respect to F2. Okay. So this sine and cos are applied to F1 and F2 there is no sine and cos term applied. That will give me angle with respect to F2.
Sir, can you derive again that tan theta is equal to f1 sin theta upon f1 cos theta plus f2? Derive that formula. Can you derive that
See,
formula?
this is F1, all right, and this is F2, all right, and this is your resultant R, okay, and this angle is alpha, okay, and let's call this as x-axis and this as y-axis, all right. So summation fx is equal to f2 plus f1 cos theta, okay. Summation fy is equal to f1 sin theta. That is equal to what? On the right hand side, it will be for r, it will be r cos alpha, and this will be r sin alpha. All right. So this is 2 and this is 1. Okay. So 2 divided by 1 gives me tan alpha is equal to f1 sin theta divided by f1 cos theta plus f. Right? So we get the same expression.
Okay, sir. Thank you.
Sir, what is the line dividing 30 degrees and 25 degrees?
A line divided by.
Line dividing 30 degrees and 25 degrees.
So this is the x-axis, horizontal axis.
That's now.
Okay. So the angles are given. The force angle of the forces are given with respect to the x-axis.
Okay, okay.
Sir, R is 5401.
Okay. So that is 5.4 kilonewtons. Okay. So if the forces are given in kilonewtons, there is no need to convert it into Newton. Okay. So you can, since both are given in kilonewtons, you can directly apply the formula as a kilonewton itself. If one is given in kilonewton, other is given in Newton, then you have to convert it. But if the units are consistent, then no need to convert the units. Okay. So also tell me alpha. So correct. This is 5.4 kilonewtons. So that is the correct answer.
37.34 degrees.
37.34 degrees. Correct. Right, 3 4 degrees. Right. So these are the final answers. Right. So angle made by R with angle made by R with respect to horizontal is equal to 37.34 minus this angle, that is the minus 25 degrees. Alright, so that is equal to 12.34 degrees. Okay, so the final answer should be something like this: 5.4 kilonewton, and direction of the resultant with the angle marked on it.
Sir, can you show the previous slide? Okay.
Done. If anybody has any questions, please ask.
Sir,
Yes, your voice is low.
sir,
Just adjust your. Yeah, go ahead, go ahead.
can we resolve these into components and then solve like 4 kilonewtons, so we can see 4 cos 30 plus 2
Yes, yes,
cos
you can do it in
25 and
that way. So you want to do, see. Let me just. You can do it this that way also. All right, but
yes,
uh, we have already. So let me just do that quickly if you want. Okay, so this is the x-axis.
yes,
Okay, and this is my y-axis. Okay, so this is my y-axis. All right. So now since we have only two forces, so we have you can just use the law of parallelogram and the equation for the resultant. Okay, so when there are more, so as we are going to proceed for more than three forces, more than two forces, then you will have to resolve. So as you can like just like we have done in the derivation, you can do summation fx as a cos component of 4, that is 4 cos 30 plus 2 cos 25. So that will give you summation fx. Summation fy will be, say now we have to take some sign convention. So all those things we have not studied. So that is equal to 4. So here a sign convention is right hand side positive. So this is 4 sine 30 minus 2 cos, sorry, 2 sine 25,
25
and then you do a resultant by adding summation fx square and summation fy
plus
square.
fs.
All right, so that will also give you the same answer.
Yes, thank
Also,
you.
why did you subtract 37.34? We could just say that the resultant is 37.34 degrees from the
Why
F2.
did I subtract 25 from 37.34? Right? Right? That is what you are saying, right? Why did I do this? Na?
Yes.
So whenever you are representing the resultant, na, you have to either represent it with respect to x-axis or y-axis. Okay. So that is
Oh,
just the convention followed. So
oh,
right now that 37.34 it with respect to this angle. So
okay,
this is 37.34. This is your R and this is 37.34. Okay.
okay.
So if you are somebody is reading some, if you want to pass this information to someone else, then if I just write R at that is equal to 5.4 kilonewton at an angle 37.34, I really don't know where I have to, from where do I measure this 37.34, right? I can measure it from anywhere. Okay. So the established convention is if you are, you either measure it from the x coordinate or y coordinate, and when I represent it with this horizontal line and the arrow above, that means the angle is in the first quadrant. Okay, and it is on the positive side of the x-axis. If I write it this way, that means the angle is in the fourth quadrant and it is on the negative side of the x-axis. Okay. If I write it this way, the angle is with respect to the vertical axis. So this is how the convention is. Any other question?
Sir, can
Can
you
we go to the
explain
next?
tan alpha formula again?
Can I explain what?
Tan alpha
The
for
which formula?
tan alpha.
Tan alpha. Okay, okay, okay. All right. Let me just derive this. Right. So let's make this as x-axis. Okay, this is my x-axis. Perpendicular to the x-axis is my y-axis. All right. And I'm just going to extend this, and resultant is, let's say, somewhere over here. I don't know where the resultant is. I'm assuming it. Okay, and this is the angle alpha. All right. Now we are going to resolve these forces with reference to these axes, x and y axis. So summation fx, okay, with respect to the axis which I marked, will be, so let's what we have called this as this is F1, 4 kilonewton is F1, and 2 kilonewton is F2. Okay, you can mark anyone as F1 and anyone as F2. Yes, and this total angle, this is
દાદા તમે
theta.
બહુ કર્યું.
અરે વાલા સાત વાલા કરને નહીં લાગે.
All right, so let's do summation fx. So summation fx will be f1 cos theta, and f2 is already along the x-axis, so plus f. Right? And summation fy is equal to, and just write it just with some space, f1 cos theta plus f2, and summation fy is just f1 sin theta. All right, and resultant is this r, and angle made by resultant with respect to the x-axis I have taken it as alpha. So the x component of resultant will be r cos alpha. All right, and y component of the resultant will be with respect to y-axis will be r sin alpha. So let's call this as equation 1 and this as equation 2. So 2 divided by 1 is tan alpha. So that gives me f1 sin theta
Okay, sir.
divided by f1 cos theta plus f. All right. See, the trick to remember is, see, there is some force on the numerator and the same force on the denominator. Okay, so let's call this as force 1 and this is force 2. Sorry, this is force 1. Okay, so force 1 is on the numerator, it is divided by multiplied by sin theta, denominator it is multiplied by cos theta, and the second force, force 2, is left as it is.
So, sir, which force will be greater will be on numerator side, na? Means,
No, not like that. See, what I am doing, I am calculating the direction of resultant with respect to F2. Okay, R
okay,
with
sir.
respect to F2. So whatever I am with respect to the whatever I have taken it as x-axis, that with that I am calculating the angle.
Okay, sir, got it.
Right. If I take this as F2, F1, and this as F2 and this as F1, then it will give me angle with respect to the 4 kilonewton. So let's try that. Let's do that. Okay. So let's make this as F1 and this as F2. The resultant is not going to change. Okay, so F1 is 2 kilonewton and F2 is 4 kilonewton. So resultant is going to be same. It is going to be 5.4 kilonewton because the angle between the two forces is not changing. This angle theta is 30 plus 25, that is 55 degrees. Right. But now I have interchange F1 and F2. So I get this tan alpha is F1 sine theta divided by F1 cos theta plus F2. Alright. So remember alpha is now marked with reference to F2.
F2.
Okay. So R, angle of R, that is alpha, is marked with reference to F2. So let's calculate this alpha now and tell me the value what you're getting.
Sir,
Yes.
12 point.
sir here, sir here cos theta is angle 55, right?
Yes. Theta is not changing. Theta is
And
remaining
sine
same.
and in sine theta is also 55.
Yes. Yes. This theta is 55. This is 55 degrees.
Okay, yes, thank you.
Remember F1 is now 2 kilonewtons and F2 is 4 kilonewtons. So calculate and tell me the value.
17.65.
17.6. Okay, 6 I am getting. So now I have got this resultant R with respect to F2. Now my F2 is 4 kilonewtons now. Okay, so I have got this angle, that is 17.66 degrees. So the angle which I have got earlier with respect to 2 kilonewton. So how do I get that? So 55 minus 17.66, that is equal to 37.34 degrees, which is the same as I have got in the earlier case. Okay, 37.34 degrees, which I have got in the earlier case. All right, so you can get the same angle in whatever way you apply the formula. So don't mug up the formula, try to understand it, then apply it. All right, any questions?
No, sir.
Okay, so let's continue. Next question. Two forces are applied as shown in the figure to a hook using a trigonometry and knowing the magnitude of P is 600 Newton. Determine A. Yes.
Sir, you can mute him.
Yes, Gopal. Your mobile is switched. Your audio is switched on. Huh? It is creating disturbance. All right, so let me just recap the question. The two forces are applied as shown in the figure to a hook using trigonometry and knowing that magnitude of P is 600 Newton. Determine the angle alpha if the resultant of the two forces applied to the support is to be vertical. Okay, is to be vertical. And the corresponding magnitude of R, angle alpha is less than 90 degree. Okay, so these two things are given. Yeah, so let me just, so these are concurrent forces and they are intersecting at the center of this hook, center of curvature of this hook, and this is the x-axis and this is the y-axis. Okay. Right. So this angle is alpha. So the angle made by the force is 90 minus alpha. Right. So if I just extend the line of action of this force, this angle is 45 minus 90 minus alpha. So angle made by the P with the vertical is 40 minus 90 minus alpha. Okay. So what is given? The resultant is vertical. So summation fx is 0. All right. Okay. And let's do a sign convention. Right hand side is positive. So all the forces in the right hand side are taken to be positive. And let's resolve the two forces, that is P and 900. Okay. So P is given as P is equal to 600 newtons. Okay. P is 600 newtons. Okay, so let's resolve the 600 newtons and the 900 newtons in the x direction. So summation fx is equal to 0. So 900 cos alpha minus P sine 45 minus 90 minus alpha, whole thing into bracket, and this is equal to 0. Alright, and substitute P is equal to 600 and find the value of alpha. Yes, anybody calculate? Simplify this equation a little bit. Pardon? I didn't get that. What was somebody was saying something?
Sir, can you do the calculation something complex?
Pardon?
Sir, can you do the calculation?
Using what?
Sir, I can't find the alpha. It is something complicated.
Okay. Can you do the calculation using what did you say? I didn't get that last part.
Sir, I have got answer as 900 minus 300 root 2 cos alpha minus 300 root 2 sin alpha.
So you click on that shift and click that SD button
Okay, sir.
on your calculator. Shift SD. It is above that del sign.
Sir, 72.24 is alpha.
Correct. So alpha is
72.24.
72.24 degrees. Okay. Anybody else getting a different answer? Okay, so this is correct. So, do you know how to use the equation function in the calculator? Is anybody using that? Are you familiar with that? You can directly, actually, you don't have to. So I am guessing that you have resolved, expanded this equation and then calculated the values, right?
Yes, sir.
Or have you calculated directly using the calculator?
No, sir, I have expanded.
Expand. Anybody who has used the calculator equation function and solved it? Oh, all right. So I will post the procedure how to use that calculator no, equation solver after the lecture. So as a homework, go through. I will post a video in your what you say chat later. So go through that video and try to solve this equation using that functionality in the calculator. So it is much faster. So and then we will discuss that tomorrow. Okay. All right. So for now this is fine. So alpha is equal to 72.24 and now calculate the resultant. Okay. So resultant R is equal to 900 sine alpha plus 600 cos alpha minus 45. So I am resolving both these forces in the y direction because it is given that the
Sir,
resultant is, yes,
R is 1390.
correct. R is 1390 or 91 newtons. Okay. So summation fx is 0. So R is nothing but summation fy. Okay.
Yes,
All
sir,
right.
got.
Okay. Any questions before we continue to the next? All right, so
No,
let's
sir.
continue. Okay, so now let's expand this topic and let's go to a system where more than two forces are present. So you have three types of force system that you will be studying. A concurrent force system. In a concurrent force system, all the forces coincide at a single point. Okay, so that type of system is called as a concurrent force system. Okay, Second type is called as a non-concurrent, non-parallel force system. Okay. In this, the forces line of action of the forces is not intersecting at a single point. Okay, so this is different. This is different. Okay, so these forces, if you extend the line of action of the force, they will not intersect at a single point. So such a system, and as is called as a non-concurrent. And why non-parallel? Because none of these forces are parallel. Okay, so that is how you describe the system: non-concurrent, non-parallel force system. Okay. Third type is the simplest type, that is a parallel force system. In this type of force system, all the forces are parallel with respect to each other. Okay, so all forces parallel with respect to each other. So these are the basic three types of force system. So let's start with the first type, that is the concurrent force system, and let's see how to derive the what you say, the equation for the resultant. Okay. So in a concurrent force system, all forces are acting at same point. Okay, and they are in same plane. So all the force system which we'll be studying will be coplanar force system. Okay. Now, when you say concurrent force system, this forces may not be in physically contact with each other, as shown in this figure. But when you extend the line of action of these forces, so this might be something like this. All right. Okay. But when you extend the line of action of these forces, they should intersect at a single point. Okay. So now let's see how to calculate the resultant of this force system. So take
Sir, but forces from more than one plane can also intersect at a point.
but we are dealing with coplanar force system. Okay, in this
Acha.
course, so
Okay.
that becomes a three-dimensional force system. Okay, so
Okay.
by definition, we will be dealing only with coplanar
Okay.
force system. Yeah, correct. So that will be a three-dimensional force system. Okay. Now to calculate the resultant of concurrent force system, take the point of intersection of all the forces as origin. Okay. Then resolve all the forces. So this R is marked as the resultant of the force system. So your force system consists, the shown in the figure, consists of four forces: F1, F2, F3, and F. Okay. So resolve all the forces along x and y direction. Okay. For example, this force F1, if I resolve this force F1 along x direction, it is F1 cos theta 1, and F1x cos F1x is F1 cos theta 1, and F1y is F1 sin theta 1. Okay. Then add all the forces. Okay. So find out summation fx and summation fy as we have done earlier, and apply some sign convention to the addition of forces. This can be anyone, but whatever sign convention you choose, that should not be changed. You have to apply it throughout. Okay. For example, right hand side, all the forces on the right hand side are taken as positive. All the forces acting upwards are taken as positive. Okay. This is generally what I follow. So right, all the forces which are in right hand side are positive. All the forces acting vertically up are taken as positive. Okay. Then find the resultant by squaring and adding summation fx and summation fy, and then take the square root of it. So this will give you the result. Okay. Similarly, find the angle made by the resultant with the x-axis by using the equation summation fy divided by summation fx. Okay, that is the tan inverse of summation fy divided by summation fx. All right. Any questions? Do you want me to go through the method one by one?
No, sir.
Okay, so if I want, so let's, as shown in this figure, if I assume that the resultant is in the first quadrant, so by mathematical calculation, if the resultant comes in the first quadrant, so if this is the resultant, okay, so the proportional summation fx and summation fy will form this type of a triangle. Okay, so this will be your summation fy, okay, addition of all the forces in y direction, and this will be summation fx. Of course, I am assuming, so why I am writing it in this way? Assumption R is in first quadrant. Okay, that means summation fx is in the right hand side direction and summation fy is vertically up. So when these two conditions are met, obviously the resultant is going to come in the first quadrant, and this is how you represent it in the form of a right angle triangle. The summation fx becomes the horizontal side of the right angle triangle and summation fy is the vertical side of the right angle triangle, and this angle made by the resultant, now we are going to find out with respect to the horizontal x-axis, and that is given by this equation, that is tan inverse of summation fy by summation fx. Okay, let me just draw it over here again. Okay, so this is R, this is summation fy, and this is summation fx, and this is the angle theta. Okay, you can also represent it in this way. This is summation fx, and this is summation fy, and this is the R. Okay, so we have reduced the multiple force system into a two force system. Okay, this is the equivalent to force system, and that is how you calculate the result. All right, any more questions? Any questions? Okay, so let's do a small example before we conclude. Okay, 5 concurrent coplanar forces act on a body shown in the figure. Find the forces P and Q such that the resultant of the 5 forces is 0. Okay, so the resultant is given as 0. Okay, so summation fx is 0. All right, so let's calculate summation fx. So resolve of one forces one by one. So let's start with 40. So horizontal component of 40 will be 40 cos 60. There will be no x component of 50 Newton force. 30 Newton force is in opposite direction, so it becomes minus 30 plus the way q is marked, q cos 20 is equal to 0. Alright, so calculate q. Similarly, summation fy is equal to 0. So upwards, assuming upwards positive. So this will be 50 newtons plus vertical component of 40, that is 40 sine 60 minus q
So
sine
Q
20.
10.75.
Correct, 10.7, 10.64 I am getting, so that is okay. 10 points, I am getting it 10.64 newtons. There might be some approximation error, just check it.
Yes.
Minus q sine 20 minus p is equal to 0. So substitute this value of Q in this equation and find out the value of P. Anybody getting 10.64?
Yes, sir.
Okay.
Yes, sir.
So there might be some error that you might have done. So 10.64 is the correct answer. Calculate P and tell me the value.
81.01.
Pardon?
81.
81 newtons. Correct. All right. All right. That's all for today. I have posted the earlier lecture notes in your class materials folder, so you can download and check it. I have also uploaded the question bank. So we'll stop for today. All right. Thank you.
So,
You can. Yes.
so today's PDF also, will you please
Yes.
upload
Yes.
that?
Yes. Today's PDF also I will upload. So I am going to upload the notes lecture by lecture. All right.
Okay, sir. Thank you.
Okay. Okay. Thank you very much. Bye. You can go to the next lecture.